Okay, good morning, everybody. It's for the recording. It is June 30th and Thursday, June 30th. And today we're going to do Python handling text files, notebook 9 notebook 8, and intro to Pandas notebook 9. Get into the intricacies of how how Pandas syntax, Python syntax handles basically a spreadsheet. Okay. With no further ado. Okay, get over into my Anaconda Explorer. That's not where I want to be. And I want to sort by name, not modified, OneDrive. Documents Python. Real quick here, guys, before we get going too far, I can't remember if I told you, create a TMP folder at the same level as your notebooks and your data. I think it's this lesson. Pretty sure it's this lesson. We'll be writing a file to a TMP, and if you don't make sure it's created first, it seems like you get an error. So it's okay if you get that error, but it seems like you can't open a file in a folder that doesn't exist without crashing Python. And of course, you know, there is exception handling you can write to handle that, but it's not in my instructional notebooks. So yeah, TMP folder at the same level as data and notebooks. Coming up into notebooks. And yeah, number 8, Python and text files. Okay, and away we go. Now, if you've done much work with programming beyond just the simplest tutorials, you've done file handling. But, you know, of course, Python has its own syntax. So we'll cover that. But the reason you might use this as an analyst, data or file handling, is as you're moving through data and using these data frames and spreadsheets, and you're, you know, filtering rows out, and you're eliminating columns and formatting things, and deriving, you know, calculated fields and whatnot. You may want to write out kind of like an informal report. I don't think too many people do old school text file reports, you know, for, you know, mass consumption anymore, but you might. But more than likely, where this would be useful as an analyst is within your Python code. You can perhaps write out output that lets you test your code, instead of doing it interactively like we're doing with this Jupyter Notebook. Jupyter Notebook's great for prototyping and learning. But when you're actually, you know, producing code, running it in a production environment, it's much more likely to be run in a script with really no human intervention. So an output file might help you, like a log file almost, might help you keep track of what's going on or what happened, or, you know, just to be, you know, satisfied that the result was what you were looking for, and that it ran successfully. So anyway, I'll try not to belabor the issues here because they're very generic to computer science. Okay, so you got a couple kinds of file access: direct access, where you can reach right down into a file. We don't do a whole lot of that. And then there's sequential access, where you open up a file, and your computer program, your Python program, reads from the beginning and runs down sequentially. That's pretty much kind of how we're going to be working with it. So you got 3 steps to opening a file. Make sure that you do each of these in your program. You need to open the file, which for Python is creating a file object that then has methods, that you can operate on the file. So you open the file, you do what you got to do with the file, process the file, and then make sure you close it. It's kind of like if your computer crashes and you've got like a Word document or a PowerPoint open, it can have they seem to be getting better and better and better at it over the years. But there was a time when if you had an application open and you shut your computer off, it corrupted the file or could have bad things could happen. So we always close the file elegantly. May seem obvious, but we also often forget to close the file in your program. Nobody forgets to close Word because it's there on your screen and you click on the X and but when you're the programmer, it can slip your mind. So yeah, we got a file object name. This is a generic identifier, and we use the Python open function. It's part of the base library. Don't need to include any, or the base language. You don't need to include any libraries. And there's a mode parameter. The first parameter is file names. And the next parameter is the mode. You can open for read only, which is the way I work on things. I've never had to write an application where I have to open something for read and write. So yeah, open for read is like an input file. Open for write means you are writing out to the file. And append, yeah, where you add wrote to the actual file, to the same file that you opened. I did a lot of this kind of stuff back in the day. Never worked with that, but there are certainly applications for that. Okay, so yeah, we've done a little bit with file names, but here we'll go over what that no kidding is. So some examples of opening up and having a somewhat useful name, output underscore file, as opposed to just file. So we're opening in the same directory because we've got no directory information here. We're opening a file called taxresults.txt for write. So we're going to open it up. And actually, in that example, it likely does not exist. And if it did, we would overwrite it because when you render, when you open up something for write, it's a clean slate. So remember that. And in a different directory, I use this R syntax, and as I remember learning it, and now I've learned it, I've whatever you call that, internalized it and forgotten about it. So from what I remember learning about this a few years ago, the R at the beginning tells Python basically, okay, really, I'm using a backslash here. Don't interpret it to be like a special character like slash n, is the new line character and whatnot. It means, no kidding, in this literal string text, don't interpret anything to be anything. But if there are no special characters in there and you leave out the R, it still works, but it's safest to leave the R in there. And I went back and forth with that a couple of times early this morning. And I took the R off and it didn't break, but I don't think I had any special character. The backslash n, like down here in the new line, in this first code file, for sure is a new line character. There's a few others. I think backslash T is a tab character. So yeah, anyway, just beware of that. So this R, putting R in front of it never really hurts. It only helps make sure that it gets interpreted correctly. And yeah, input file, we're opening for read R in quotes there. Don't forget, it's a string literal, not just the letter R. Okay. Writing to a file, pretty straightforward. We're going to open an output file in our current directory. So for me, that's my notebooks directory. Hang on a second. I want to go up here to my Python directory. Do this in parallel. Parallel notebooks. Element of PDF. Grail.txt. So since I've done this before, of course, I'm going to delete that. Go back over here. So I don't have a grail.txt in the current directory. So here's some syntactical examples. We're going to open a file object, create a file object called output file by using the open function, passing it the file name grail.txt, and we're opening it for write so that we can write out to it. And then we use a method. We name the file object that we're writing to, we call the write method, and we pass it the stuff we want to write out there. It's very much like a print statement, but instead of going to the console, it goes out to that file. So we're going to write, and then this new line character /n. If you don't add that, it will append your text to the same line. So you got to add that /n to make it go to the new line. Now, when I was young, there was a command called write line. I remember write ln in Ada or Pascal, one of the languages I worked with. And write line automatically put that in there. And if you said write, it wouldn't. So it embedded that in the command. There you go. Different computer languages. So we're going to write out Sir Robin and a number, and we're going to write King Arthur and another number. And you won't see, but we're not closing the file yet. So I'm not going to go look at it yet, but I am going to see that it is created. I'm not going to open it. Refresh. If I go up one, I'm reminding myself if it, yeah, so it shows up, but it's not closed yet. So I don't want to open it or click on it or anything, because then I might fall into the matrix. Okay, so we set a variable equal to sell price is a floating point variable, but whenever you're writing to a file, you have to convert everything to string, and don't forget your new line at the end. Okay, that's interesting. I see the numeral 5 down there. And the numeral 9 up here. Huh. I'm not even sure where that came from. Huh. Okay. So now, once we're done writing, what do we got? Sir Robin, a floating point number, King Arthur, a floating point number, same floating point number. And then we've got 8.24 down there. We will close that file. Okay, so now that output file is closed, I'm going to go out with Explorer, which you can do with either this Explorer, Windows Explorer, or you can do with Jupyter Explorer. I'll prove that here just real quick. Grail.txt. And there is our Sir Robin, King Arthur, same floating point number, and 8.24. But if you don't want to go out to Windows Explorer like this, you can use this Anaconda Explorer similarly, and it is friendly to text documents and whatnot. It's not just for notebooks. So if I go down into my notebooks directory and I go down alphabetically. All right. Or does it? Oh yeah, it groups notebooks together, which is handy since it's for Jupyter Notebook. But down here, Grail.txt, in our non-notebook files, alphabetical letters, same thing. So you can click on a data file, check out your data file or a CSV in Anaconda Navigator while you're in Chrome or whatever other browser you're using. And you can explore files. It's not just for notebooks. I don't know that I ever really made that clear, but it works great. Okay, so back to our main file. Okay, now appending file to a data. So you can open, now that we have Grail.txt out there, and I don't have it open in Notebook or anything, cool. We can open for append, and we can write out this stuff. Always remember to convert numbers to a string, and then close it back up again. Don't forget, close it back up. So let's go look at that real quick. Grail. And there's our preview. And sure enough, there's our additional stuff. So open for append automatically goes to the last blank line in the file and sticks it there, just like you'd think. Okay. So now that we've created Grail.txt in the current directory, we're going to open it up, and we're going to read line, which we're creating a file object. The fact that we named it in file doesn't mean anything other than to our human mind. It's the fact that we opened it for literal R, that now we are opening Grail.txt for read. So we use the in file object read line method, and we don't need to pass any parameters, and that'll read a line, and then the read line automatically sets the line counter to the next line. So while it looks like we're doing the exact same thing here, the file object keeps track of what line you are on. So so you're not reading the first line every time. You know what I mean? It automatically increments down. You don't have to loop through it. So and then I used the type function to tell us what in file is, and then I closed it, and then I print line 1, 2, and 3. Well, there we go. Why all the blank lines? Because you've got an additional the read line and the /n are kind of redundant, so you can strip those using a string method, rstrip, because every line you read in, it's kind of like input. It's kind of like the input function. It defaults to string, so you can use the string method. So yeah, let's run that again with the strips in. And now we don't get the extra blank lines. So it's just something to remember when you're processing file data. So I'm going to put those back where I had them, because sure enough, if I don't put my toys away, I'll trip over them the next time I go to play with them. Okay. Now reading numeric data. So here we're going to use one of the files that's posted on the classroom, and we're going to open, we're going to reuse our name. Well, we're saying in file without the underscore this time. So, but anyway, yeah, once you close in file, it's not really useful anymore. And actually, no, I'm not gonna belabor the point. Once you close in file, you can't do anything with it without reopening it. In file equals open, and here we're using the R to make sure that we're reading these \n in numbers correctly. So real quick here, because I got time, I think. Yeah, I got time. Real quick, I want to do an experiment because I haven't in a while. So sometimes you got a chunk of code in a Jupyter notebook that you want to separate out. So if you just say edit split cell, bang, it splits it right where the cursor was blinking. So I want to run this without doing anything else. I want to open that. So, okay, so no news is good news. I didn't get an error, but let me remove that real quick and see if this is one of the cases where, yeah, invalid argument. It does not like this backslash. Especially, I know this one is problematic, the /n. So that's why I kind of just default to using it no matter what I'm doing. I have like a mental mnemonic. Really, really open this file. There's no tricks here, no special characters. So let me go back and run that again. Okay, so now we have in file open for read. And we are going to read in 3 lines, in file.readline, in file.readline, in file.readline. And because they come in as strings, we're going to convert them to float. And as we've talked before, if you try to convert an alphanumeric string to a float, it'll error. So there's all kinds of error proofing that you would need to do in production code, but it slows us way down just for going through the syntax. So we're going to read 3 lines into 3 different number variables, and we're going to create a variable called total that is the sum of all 3. Print out the individual 3, print out the total, and then close out the file. Simple enough. And there we go. Okay. So normally when you're opening up an input file, particularly on the input, but anyway, yeah, typically you're going to loop through a file. So we'll have 2 examples here. We will while through it and we will for through it. Okay, so they're just a few lines of code, but yeah, if you had an input file that you were processing with base Python, not pandas, we'll see here in the next hour, give or take, a lot of this is basically handled for you. So we are going to access some files with loops. So the general procedure is to open the file for outputting, loop through the input data, and then write each whatever output to the file, and then close the file. So it's very straightforward. Reading to the end of a file with a loop, we can do 2 ways: a while and a for. So the first one we've got here is a while loop, and it's while the read line does not result in a null or quote. So basically, while we have data to read, we will continue to process. So we are going to open up. Did we close? We did close numbers, right? Yes, we closed numbers in the previous code. So in this next chunk of code, we're going to open it again for read. We're going to prime. Remember, it's just like the looping exercises we did with entering a ticket price to get in the zoo or whatever. You got to, outside the loop, you got to do whatever you got to do, setting things up so that the first time you hit the loop, it's true and it will actually enter the loop. So that's what we do with file processing. Is you read the first line, and if for whatever reason the file's blank, it won't do anything. anymore. Kind of almost an error, but not really. If you open a blank file, and you try and process it, this first read will return a null. Well, it's okay. That's okay. It doesn't care. But as you enter this loop, if numbers.text were null, it wouldn't do anything. It would come out here, and we would this print statement wouldn't print anything to the screen because there's no data in the file. So that's what we're doing with our while loop here. While line, which is what we're reading from the file, while line is not equal to null, num equals, we're going to convert line that we read out of the file to a floating point, and then we're going to print that number, and then we're going to read another one. So now the while, it's while more records, do while more records, generically, do while more lines in the file. It's going to just go and print num. If you've got 10, great. If you've got 10 million, I don't know the file system would handle that, but you get the point. And then outside of the loop, when we're all done, don't forget to close. So bam, there you go. Luckily, it's a nice short file. So that's how you while loop through the, but generally, since an input file is something that you want to process all the records, generally speaking, and if you want to do something for a predetermined number of times, generally speaking, you use a for loop. You don't use a while loop. You don't use a condition-based loop. You use a for loop. But anyway, we'll get to that in a little bit. Don's sample text.txt file. Okay. I think I added this to, by the way, my buddy Mike Ellis, Dr. Ellis, the author of a lot of this stuff, is going to come in August 2nd and do some more advanced techniques like regression and supervised machine learning and unsupervised machine learning. So a classifier and cluster analysis are the main types of supervised and unsupervised machine learning. And that's all about Python and pandas and whatnot and libraries. So yeah, that'll be great here in another month. So I'll get to shout out to him personally for all of this good content. So anyway, we're going to open up my sample text.txt. I may be giving away, but I want to look at it real quick. Sample text.txt in data. Python data. I didn't look inside this thing when I went through here again. Sample text. Where are you? Sample text.txt. Whoop. Ah, okay. I remember. I remember now. A couple of points I want to make here. So we're opening up sample text. We are going to read line before our while loop down here. We're going to read, and then we're going to strip the new line character off. And then we're going to say while input record is not equal to blank, print input record. Okay. Okay, this is purely sample data for Python programming exercise 12345, 123.45. Okay, then there's a point I'm going to get to here in a little bit. Using the for loop. Okay. So I think I'm giving away my thunder, but I want to show you again. You'll notice blank, blank, Mary had a little lamb, woo pig suey, right? That didn't get displayed. And we'll show why that is here in just a moment. So using the for loop is similar, but it's more, it's less lines of code, and it rips through that file until you get to the end of the file. It's not checking each read for null like we were up here, like this condition. It is checking for, I'm pretty sure it's a special character, that EOF marker, end of file. So we are going to open sample.txt again, which I did close, yes, and continue processing until the end of the file. So for line in file, and I say, yeah, I gave away my own surprise. So we're not doing any stripping, right? We're not stripping the new line characters. So we get the new line character that's automatic from the print, and we get the new line character that was in the input file, and we get these additional lines, Mary had a little lamb and woo pig suey, that we didn't get before, and I gave away my thunder. But let's see who was listening. Jeanette. Why am I saying Mary had a little lamb here on the for loop and woo pig suey, and I didn't see it before?
Sorry, realized I was muted. It's from the sample text.
Correct. Why am I seeing more output here? Why am I saying Mary had a little lamb and woo pig suey down here in the for loop, and I didn't see it in the while loop? You want me to move
Scroll
on?
down to the other one. Yeah.
You want me to
I
move
wanted to
on?
see like what? Oh, I just wanted to compare the two codes to each other and see.
Yeah, well, I was just talking about it. Does my voice just drone on?
Well, sometimes I get caught up in looking at the output. And so, yeah.
Well, let me let you off the hot seat and let me put somebody else on the hot seat. Seth, are you with me, buddy? Seth? Is he still? Yes, still in the classroom. Seth? That could explain things. Edgar?
I'm here.
Hey, buddy.
Hey.
So why am I seeing Mary had a little lamb and woo pig suey in the for loop, and I'm not seeing it in the while loop?
Let me think.
I was just explaining that for the last 3 or 4 minutes, I was explaining why that is.
I'm not sure.
Okay. Kevin, you with me?
Yeah, is it because you're not stripping the lines? Is that what you said?
Well, that's why I got extra lines here. That's why I got blank lines, because the print sticks a blank line in there in addition to the one that is actually in the, at the end of the line in the file. So that's why I got blanks down here compared to up here. But why am I seeing Mary had a little lamb and woo pig suey in this as a result of this file processing I did in a for loop, but I'm not seeing, it's the same file, sample text.txt. Why? But I'm not seeing it up here in this output. Why is that?
Does the for go through like all of the text file and then the while will just do a part of it? Or does that make sense?
It does. It's leading up to the correct answer. Okay,
Yeah,
so
sorry.
Go ahead,
Can I
Ken.
try? Is it, well, the while says it's while the input record is not like an empty string, right? So would the blanks down there count as empty strings?
The blanks, yeah, I'll let you guys off the hook. But okay, we're all adults here, and this isn't college. But I explained this real clearly in the 3 minutes before I started asking questions, and I'm afraid you guys are working That's what I'm afraid is happening, is that you're distracted or working or whatever and aren't able to hear what I'm saying or aren't able to concentrate on it. So let me go over this again. In a while loop, yes, our while condition is checking for a blank line. So we're only going to read until we hit a null string, a blank line, as opposed to the for loop, which goes through the entire file, checking for the end of file marker, the EOF, which is at the bottom of the file, regardless of if you have blank lines or not. And that's why it's more normal, more reliable to use a for loop to process through an input file than to use a while loop. So the while here ran into, are you seeing sample text? Are you seeing that in lines 1 through 7? Is that, am I sharing my screen right?
Yeah.
Yeah. Okay. So sample text has 2 blank lines in it. So if you use the while loop, it's the same reason Excel freaks out when there's a blank cell or a blank line and you hit, control down arrow, it'll go to the next blank cell. It doesn't go to the very bottom of, what I mean? Blanks are bad, nulls are bad when it comes to input. So in this case, it's just a good example of why using a for loop, which literally you can't see it, but out at the end of Woo Pig Sooie here, there's a special character that is the end of file marker. So that's why the while loop terminates when it hits the first blank line in the file, but the for loop keeps reading and writes out Mary Had a Little Lamb and Woo Pig Sooie. Okay. So if you just want to blast every line, you can open a file for read, and then the f.read, you can print the file object.read method, and it just iterates through the entire file. No for loop, no while loop, no conditions, doesn't worry about blank lines. It just reads and prints the entire file. So that's almost like I think it was Unix, where you list a file or something like that, and it just burps it out to the to output. So that's very similar. Okay, let's take a break, and then we'll do a little bit more. But I want to get the pandas before we get going too far here today. So I'll just blast through those. But let's take 15. See you back at 9:30. Okay. I don't think there was a lot of interest generated there in my discussion of text file processing. So I'm going to move on. Here are a couple of programming examples of moving through a file and doing the same sort of computer science logic that you would do as you move through that file, reading in, writing out. Another great example down here. So I believe this notebook 8 gives you code examples of everything I've talked about and everything that you need to process a text file. So if we were doing an exercise with pandas and you were asked to create a log file as you went through, you've got everything you need here. So I won't belabor the point, but there is a programming exercise at the bottom here that may come back to. So I'm going to move on to pandas. So let's see here. I always want to sell all output clear and hit my floppy to create a save point and file, close, and halt. And we don't need sample text tab anymore. So I go back to Explorer, and inside of your notebooks directory, hopefully you have downloaded number 9, Introduction to Pandas. So yeah, this is where the magic happens, but it's also where it starts to get complicated as far as, I mean, it's moving more into data analysis, but you also gotta pay attention. So yeah, got a shout out to my buddy Mike Ellis. We'll be seeing him August 2nd to implement some of this stuff in some of its more advanced capabilities. Okay, so we've imported a couple of libraries, but here we're going to really see why Python is so popular. I don't know that anybody does anything in the world of analytics without dealing with the Pandas library. And again, those are self-contained chunks of capability that are generally, if they're installed on your workstation, but they're not necessarily in the language, you have to overtly import them in order for that that capability to be in memory and ready to go in your program. And one of the most fundamental libraries, of course, is Pandas. So there's a statement from the official Pandas data website, which is also accessible in our Anaconda or Jupyter Notebook help. The Pandas reference is one of the hard-coded language reference manuals for these, and these are different. These are other libraries. You got the base Python reference, IPython, which is the interactive version of Python. NumPy is very critical to Pandas and other things that folks do in analytics. And then there's another one called SciPy. Matplotlib is a plotting library that we'll use. SymPy. I think that's for the words is escaping me. Create a, anyway, and here's Pandas. So you can get to them that way. So why use a library? Because if you read everything that everybody's ever written to extend the functionality of Python, it would probably blow your 32 gigabytes or whatever of memory. There's just so many libraries out there. So that's how you compartmentalize the code. And it also lets you mentally not worry about how they're doing what they're doing. That's the magic of modular code, is that it can be tested, it can be set on the shelf, documented, where you can use that functionality when you need it, but you don't have to worry about how they implemented what they did. All you care about is the interface, which is normally the parameters and the return values. So yeah, there's a lot of code out there, and it includes these libraries. I mean, they're for real, so they include a lot of the error checking and whatnot that that we're not doing down here in these little tutorials. So minimally sufficient Pandas. There are, I think I've said this 20 times, there are often more ways to do something, more than one. Sometimes there's 20. So the philosophy here is something you hear in the Python and Pandas world: minimally sufficient Pandas, meaning knowing how something one way how something works is usually good enough. So concentrate on the syntax that works for you, or the methodology that your team likes to use. If there's a a particular way of going about doing something that your team likes, then go with that. But yeah, there's a note about minimally sufficient pandas, and it's can't remember his name. It's one of the authors of, I think he wrote the Pandas Cookbook, which is another really popular. I don't know. There's 100 at least books on just on pandas, let alone Python. But that's where that comes from. And there's a course, an entire course on mastering Python for data analysis, a couple of $100, but that's out there at that website as well. Okay, so Pandas is a library installed on your hard drive. I think we went over this a week or two ago about the MariaDB library that lets you connect to our SQL database, our MariaDB database. That has to be installed on your workstation using the console. But once a package has been installed on your hard drive, now all you have to do is import it. So that's what the Anaconda distribution is so good about. It includes a couple of hundred different of the popular libraries, a couple hundred. So anyway, all we do here is import pandas, and then the convention that everybody uses is to alias the pandas library as PD. So it's no different. And that took on my workstation about a second and a half. Seth, how long did that import take on your computer?
I don't remember it taking too long, but it was more just getting it to work at all that was the problem on my end.
Did you run? Are you with me in this code cell? Did you run it earlier in the day, or you're not following along with me? Seth?
I had 8 open, but I didn't have 9 open because I had a call that I had to answer.
Oh, okay. Yeah, guys, go ahead and open up 9 and hopefully minimize your Zoom and just follow along with my share screen, and then pop back over, Alt Tab, Alt Tab, Alt Tab, and follow along with me. I try to go slow so that you guys can do that. If I'm ever, ripping through it too fast, or I get off the screen and you can't follow along, please let me know. So yeah, the import command just brings that into memory so that you can now use it, or in your program. So the coolest thing that you see in every time you're working with pandas is to read in a data file, generally a CSV, comma separated values, that we will then read into what's called a data frame. And you see in virtually all the tutorial sites, a data frame is in just general. If you're just, we're just working with one and you're learning the language and it's, from a tutorial site, virtually everybody just calls it DF, short for data frame, so that you know what you're looking at. Okay, so we've got a data file here. This is the one I was messing with. I took my R off, which is dangerous, but it seems to work. That's what I told you. I was exploring when I can get away with it and when I can't. Just generally speaking, I stick that little R in front of a file name, whether it's base Python opening a file or working with pandas. If there's any slashes in there, I use that R in front of the string literal. So we got to have a place to put our data, right? That's what pandas is for. It's for holding data. So we say df, which is going to create an object, equals PD, and I go through this in the next markdown cell. PD is the pandas library dot notation. Remember, just like a data type dot method. Well, it's library dot data type dot method. Same, that dot notation is how you is how you fully resolve these names. So read CSV, read underscore CSV is the library function we're using. And then we pass the parameter of a file name, which is one of the 4 files that I put on Canvas, Applewood underscore 2011.csv. So that line of code, that one line of code, creates a version of the CSV in memory in pandas, a pandas object that you can then do all kinds of stuff with. So we'll run that line. And it doesn't do anything. So you're probably wanting to ask me, dude, where's my data? So yeah, just reading it in doesn't present anything to the screen. It just creates that data frame. So here's a little bit more about this object. An object called a data frame. It's a data structure. Data typing is more specific to individual values. This thing is a data structure that holds 2-dimensional data. It's like it's a table. It looks just like the CSV with one little addition after it reads it in. So that's why it's so useful, because so much data that's out there is in the form of these CSVs. So when we read in and create a data frame, it by default automatically assigns an index. And the index value uniquely identifies the row. So it, from 0 to the end of the data frame. So you can, think of that as like a primary key or like a key in a dictionary that we just covered. If it already includes a primary key value, like a column that is like employee ID or social security number or whatever, we can tell pandas when it creates the data frame to use that column instead of creating this index value. But we'll come back to that. The data frame has many built-in methods, just like string objects have a lot of methods. Data frames also have a lot of methods. Okay. So normally when you pull in some data, whether it's opening it with Excel or anything else, you want to take a look at it. So here are a few common tasks that have, single line of code, easy functionality. So we can look at the first or last few actual rows, including the column headers. We can look at the data types that Python assumed and assigned by default as you created the data frame. Look at how big the data set is, rows and columns, and then some general information. So we've got a few pandas data frame methods that we'll run through here. Some very popular ones. When you first open a CSV, first create a data frame and haven't really looked at it, you can use a method called .head, which gives you the heading, more or less, of the file. The .tail gives you the end of the file. And if you don't pass it any parameters, those default to 5, the first 5 rows or the last 5 rows. But you can, I've used like 50, df.head, and then pass in the numeral 50 and it'll give you 50 rows. But just for brevity's sake, it defaults to 5. df.columns returns a list of the column names. And then there's a couple of big picture methods, data frame methods. that will give you more information about your data frame in general. df.info gives us number of rows, number of columns, column names, how many nulls you have versus missing or versus ones with value. The data, the column data type, and how big the data frame was. Some folks out there operating with data frames that are gigabytes, so you do have to watch your memory usage. So yeah, df.info and df.describe, and you can use them very often. You'll see this. You can just type in the method. You don't have to print it, but it does look a little bit different. So anyway, we've got a few examples here that you can follow along and run. So we're going to print the type of the columns, and then we're going to use the df.head, the .head method, and look at it. Yeah, so the type of our columns is a index, and df.head shows you after we read in Applewood.csv. Remember, that's our input to making df is the Applewood 2011.csv. We get an unnamed index column. You see on the left, that 0, 1, 2, 3, and 4. That's not actually in the file. That's what Pandas creates when you read the CSV and you don't specify an index column. It creates that for you. And then we've got 5 columns in that data, in that CSV file: age, profit, location, vehicle type, and previous. Okay, so that's df.head with no parameters. So if we run it and we pass it a 10, we see the first 10 rows. And you'll notice that the index, the unnamed column on the left, is 0 based. Okay, so that's df.head. That gives you that yes, it opened the file that you thought you were opening, and you got some data in there, and it looks like what you thought it was going to look like. df.info tells you the column names, how many values there were, and then you notice there's a D type, a data type column in this output, in this .info method, that tells you the data type. So age defaulted to being an integer data type. That whole column, each column, we'll get into this, each column has to be the same data type. It's not like a Python list where you can have different, a list that has a string and a floating point and an integer and back and forth and back and forth. Each column in a data frame will be the same data type. And it defaults to this thing called object. These are, you'll see here in a minute, these are not base Python data types. They're NumPy data types, but it's a very similar usage. Okay. And then we get into describing the data frame. This is where you'll actually get, in one line, you'll actually get descriptive statistics. So poof, you've just done some data analysis in Python, in Pandas. You'll get descriptive statistics for each numeric column. You'll notice here when you execute the df.describe, you don't get anything for location or vehicle type because those are NumPy objects, which are really just strings, and you can't do math on them. So you can't do a count and a mean and a standard deviation and whatnot. So it pulls out the columns that it can do descriptive statistics and presents them for you. So you get your most important descriptive stats here with the describe. The count is the number of values, mean, standard deviation. The min and the max, of course, gives you your range. And then you've got your 25th and 75th quartile as well. 50% is your what? Alyssa. Are you with me?
Yeah, can you repeat the question? Sorry, I was taking notes.
Sure. When you are looking at the results of the described method, you get a mean for a column, and you also get a 50th percent value here. What's the difference between those two?
I'm not sure. They look very close in value.
They sure do.
Um,
The
could
50 generically
if I had to guess.
Yeah,
go ahead. Sorry.
Generically in statistics, what is the 50th quartile of the data?
Half.
It is halfway through the data. It's the median. So you got
Okay.
mean up here. And kind of the giveaway is that it's got so many decimal points. So that's literally adding up every value and dividing by the number of values. The 50th quartile is your median value. So
Okay.
very close. Our mean is 1843 and our median is 1882.5. So that might suggest that it's fairly symmetrical data. So there you go.
Cool.
There you go. Okay, so there are two main data structures within pandas. We talked about the data frame. Okay, we already seen that. And it has its own methods. It is an object. That's a class of objects, and any class has methods associated with that class that do things. Classes and attributes, that operate on that class of objects. So we got basically two classes, and I'm making this point more for the object-oriented programmers than folks that aren't super familiar with object-oriented terminology. Somewhere in the middle of that. So you've got a data frame data structure and a series data structure, and they're absolutely related here. And I go into that in the text. A pandas data frame is rectangular. It looks like a table. It's got columns and rows. It can have, a column. It can have columns of different types. Could be floating point, could be integer, could be string, could be Boolean. A series is a pandas column. So whether it's a standalone, you can work with pandas series, which we will do here. You can work with series standalone. It doesn't have to be part of a data frame. It doesn't have to be something that was pulled out of a, beg your pardon, CSV. But there's functionality to it. It's kind of like a list in base Python. Think of it like a list. It's a column of values, but there's functionality in the way it operates and everything that make it different. So we will talk more about those two types of objects. Sometimes when you have a data frame, you will be operating on only one column, and within the syntax of the language, if you are narrowing down on one column, it is a series, and you do things with it that you only do with a series. So we've got plenty of examples of that sort of stuff. Okay. So we don't need a file to create a series. Make sure I ran everything here. Yep. Okay, in this next code cell, I create a variable my list, which is just a list of what, 1, 2, 3, 4 values, and we'll print it out. So that's a Python list. Okay, so we can convert that to a pandas series, just like we can convert, a string to a floating point or vice versa. There is a pandas series method, which will convert a base Python list to a panda series. And that's what we're doing in this next code cell. So we're saying that data, and more informatively, it would be data series. I'll rename it. And then print data underscore series. And then data underscore series. I'm gonna have to put all this back, but that would make more sense when you're dealing with a series or a data frame. It helps to put the what it is in the name of the variable so that you know what you're dealing with there. Okay, so this series that we created by calling the series method, I've printed out here, and you see that it also creates, the series also creates an index, kind of like a dictionary where you've got a key and a value, and the key in a dictionary, a Python dictionary, is your index for looking up what the value is, key value. Well, here you've got index and value. And the last line of code in here, I print out the type of our Python series first cell. The sub-0 is the first occurrence in that series, and you can see that it's a NumPy float 64, not a base Python floating point. So when you get into these libraries, they even have their own specific data types. Now they normally operate, so you don't have to do a whole lot of thinking about it. They normally operate like the base data types, but it's just to kind of point out that as you start moving into these libraries, they start creating layering libraries on top of libraries and creating different objects and data types and data structures and whatnot. And you just gotta kind of know what it is that you're dealing with so that you use the proper syntax as you move along. Any questions or confusion so far? Slow me down, get me to modify something, run it a different way. Everybody good so far? Okay. So yeah. So a panda series is a column, but it also has a numeric index. You see that 0, 1, 2, 3 on the left, which is critical. All what few projects I've worked on with pandas and Python, I had to know what I was doing with indexes and accessing the data by row and column. Okay, so we can see both the sequence of the values and the indices on the left there. Now there's for a panda series, it's just like a dictionary, the key and the values. So we can call those attributes individually if we need to access them. So the square bracket, you can treat it just like you do a string, right? The index 1 is the second occurrence in that series, in that pandas series. What did I do wrong here? Oh, got to go back. Like I said, got to put my toys back where I found them. I had modified data to be data series because I wanted to illustrate that that's a terrible name. I should change that, period. Okay, so I recreated it now as data. So now I have a pandas series called data. Now when I print it out, I get 2.5, which is, you see, at index value 1, which is the second member of that, second element of that series. Okay. Let's see here. These examples may make the Panda series look like a Python list. It does. It kind of looks like one, kind of functions like one, or a simple NumPy array, which is, NumPy is a library that adds cool functionality to these base Python types. But there are differences, mainly in the indexing, the way we use an implicit index or an explicit index. Implicit is it just assigns it. Explicit is we tell it what the index might be. Okay, so here in this next chunk of code, we're going to create a series. And again, remember, this is the values in the series are this list object that we're sending to the series method. And we're saying that the index for those 4 values aren't going to be the 0, 1, 2, 3 default thing that you assign for me. I'm picking that the index for those are going to be these 4 numeric literals. I'm sorry, string literals. So we can explicitly define an index for a Panda series. So we're going to create that series. Again, overuse this name data, and then we're going to print it out, the whole thing. And you'll see, instead of 0, 1, 2, 3, you'll see the index of being A, B, C, D. And then we're going to print data at our explicitly indexed location of C. Woohoo! There you go. Explicit versus implicit indexing. Okay. And you don't need to have, just like a dictionary, remember, you don't need sequential values for your indices. So here we're creating the same, we're recreating the data series using the same values, but we're using non-sequential numeric indices this time. So we're going to create it, print the series, and then we're going to print the data at index location 1492, which is the third one over here, 2.75. Yep. So instead of C, it's 1492. Okay. No questions on that so far? Okay. We'll move into a hands-on wrangling exercise next week that might be fun. I think it's fun. Okay, so now there's and this to me got a little confusing. Was there are 2 methods that kind of replace this this bracket methodology here. See how we're looking, we're right here, and we're pulling up the it's not a list, it's a series, the series element at index C, but just using bracket notation, just like you would think, just like you do on any other series data type like that, like a list or a tuple or anything. But there is a method that is basically the same thing, and it's .loc. But there are times when you use it that you don't use this exact syntax. And then there's another one called iloc, and they are slightly different. Loc uses the actual index value. iloc uses the position, which literally, which, 0, 1, 2, 3, 4. So iloc disregards the explicit index that you gave the series and goes back to the position, which can be helpful if you're for looping through a data frame. You can still refer to the actual position in the data frame or position in the series. Okay, so data.loc is the fourth thing, which is 3.0. So I'm going to predict that's what comes out here, 3.0. And iloc is position 2, which is not really position 2. It's really position 3 because it's 0 based. 0, 1, 2, 0, 1, 2 is 2.75. So that should return 2.75. Okay. So these are different ways to get at individual members of your index. And in these data analysis projects that you run into this all the time. I know it's dry. I know you're kind of like, would you get to it? But these methods are important to any sort of data wrangling or data science project. Okay, so we have for Panda series that are the correct data type, we've got some pretty cool methods here. So we can look at the mean value of a particular series, and we're going to print that out. So we're going to print the mean of that series. We're going to print each member rounded to 1 character. So there's a round that will take your floating point values and round them to 1 decimal point. And then we're going to print and show that we haven't really affected the series at all. These methods just return a value. So it's like, that temporary, they don't actually change. They don't actually round the values. They return the rounded values. All right. So I'll run that one. And we see the mean is 2.625. And we've rounded now each of the values. So what do we have? 225, 250, 275. So everything in 25 increments from 225 to 3. So it rounded, it rounded 275 up to 8. There you go. And then this last print, this last chunk of text here, is the result of this, where we printed the entire series. So we see the indexes and the original values. So they weren't changed. It's just a return value. Okay. A couple more minutes before we take another break. Whoa! Yes.
Why does it round the 2.25 down to 2.2?
That's a good idea. That's a good question. I was noticing that myself and hoping you wouldn't ask. Why does it round 2.25 down to 2.2? And it rounds 2.75 up to 2.8. Let's look up the rules. I remember this being asked again. It's a great question. Why does Panda's series round up, or whatever? We'll find out here. Panda series round. So here's the document, the actual documentation. Round values of a NumPy array, and it might refer to how NumPy messes around. So that's this. This is the problem with the language the language reference manual, it gives you the syntax, but it doesn't really talk about phenomenon like that. So we'll go to a more informative. Geeks for Geeks is a great one. Maybe it will explain that one. And you're welcome to Google this yourself if anybody finds it. I want to say there was an explanation I found somewhere, but I do not remember off the top of my head why, because that is a absolutely legitimate question. You would think, like 0.5 anything and above would round up, and point up to less than or equal to, or anything less than 0.5 would round down. That's generally the rules. So I'm gonna take that one for homework if I can. If that'd be all right.
Yes.
Because the value at 1492 is 275. Yeah, it rounds it up to 28. But it rounds to 25 down. Yeah, there's a reason for that, and I don't remember what it is. If it's variables less than 0.5 round down, there's a reason for it. I'll find it and do a little research and get it back to you. Okay. So what we've been looking at is an actual index value, but part of the really cool capability here is that we can subset a series or a data frame column with a conditional statement. So we're going to read in a slightly larger file here called stats_exam_3_scores. And we're going to read that into a data frame. So that's another one of the files that I put out there on Canvas. So let's read that in. And then we're going to extract one column, which will convert that column of the data frame, which is a series, to just a series. Okay, so we're reading it in to a data frame. pd.readCSV creates a data frame object. And then we're going to create a series that is the data frame, and then we pass the name of the column, kind of like an index value, kind of like a dictionary key. So it is similar, familiar syntax. And then I print out the type of that scores object, and then we look at the. It also has a head method. The series also has a head method. Not every object, not every method in the data frame object has a commensurate method in the series object, but there are some that are similar, some that are the same. Okay, so scores.head gives us the first 6 members of that that series. So 1017. Need to take another break. So when we come back, we will do Boolean subsetting of that series. Let me look that up on the break. Who was that? Was that Edgar? Kevin, who was that asked that question about the rounding?
That was me, Kevin.
Me, Kevin. Okay, Kevin. I'll check it out. So let's take a break till 10:30. All right, welcome back to our third hour. The answer to the eternal question, why does Python round numbers so oddly? I found the answer pretty quickly. I remembered last time I did this. It's just because. No, I'm kidding. Let me share my screen here. It uses I think it was an IEEE standard. Hang on just a sec. Share my screen. Yeah, so I asked the question of Google, and found this post on Stack Overflow. Remember, Stack Overflow is your coding mecca, but it's often way more complex than you need. It's not a tutorial site, it's a social media site. So luckily, this is something that folks have asked, and it rounds weirdly because apparently IEEE adopted a new rounding method that is not as definitive as 0.5 and above rounds up, under 0.5 rounds down, because that introduces, because it's not exactly halfway exactly, it induces rounding errors, cumulative rounding errors, apparently. And guys, I am not a mathematician, so I'm gonna show you the answer I found. And if it ever comes up again, now you'll know that there is a new rounding method or an accepted rounding method from IEEE. Here's the Wikipedia page on it that gives you a little bit more, but yeah, IEEE 754 for floating point arithmetic. So I did not realize, because I don't think it's ever been asked prior to these Python courses, why is that so weird? But that's what happens. So there's the reason why not every 0.5 is the same as every other 0.5. There you go. Cool, Kevin?
Yes.
And that's Python. Python implements these rules, whether it's a Panda series or base Python. I think round might be in the math library. But anyway, getting off track. I do want to try and wrap this one library up here so that we can move on to some hands-on stuff. Let me see how much further I have to go. Yeah. Ooh. We'll see. I'll try and get done with this library or this notebook today. But this is the meat of the capability here. Mucking about with Pandas data frames. Okay, so we're going to print the scores to see the data we loaded. We already did a head, and then we're going to describe that series. Okay, and the when you print a series, it just to save space, it only prints 10 of them, the first and last 10. But then when we do a describe, we get our descriptive statistics here. Okay, now we can subset the data, and you get used to this, but we can subset, and instead of using an index value for the score series, we can use an expression that it will evaluate and return the elements of that series that meet that condition. There you go. So what's actually happening? Well, if we run just the condition, that's what this is. This is looking at just scores greater than or equal to 145. That creates basically an array, a series of Boolean results. It's checking each entry in scores and printing the whether or not it's greater than or equal to 145. So it sort of looks like a Boolean series is generated and then applied to our data. Okay. So before we used C, our explicit index. This time we told it to not just index equals C is what that evaluated to. This time we used a condition, scores greater than or equal to 145. So that's what it's doing. Look at each value in scores, and then create a parallel series that is the evaluation of whether or not it's true, and then just grab everything where that where that pairing was true. Okay. So we're going to do another one. Scores less than 90. And that is, I mean, super simple syntax, super powerful. But wait a minute, where's the loop? So hopefully some of you were thinking, holy crap, why is it going through the entire series with one line of code? Well, that's what it does because they're vectorized. So these are a lot of the methods are vectorized in that they operate on the entire data structure. So, normally you would have had to, if that was just like a base Python list or something, you would have had to do like we did before, right? You'd have to say like, for I equals 0 to length of list, and then if list of value is greater than 194, print true, whatever, or write the value out. So you would have had to have manually looped through that. But a lot of these methods for pandas series and pandas data frames are vectorized, and they do it all right for you, kind of like SQL does. SQL is one line of code that operates on the entire the entire select clause, whatever, however you limit the columns or rows, but it's one line of code that goes through everything. And that's what you see with a lot of pandas. Okay. So now we're going to move into the data frame, which is the two-dimensional object. So we normally create a data frame by reading a CSV. That's, like 99.59% of the time. So we're going to do a little bit of this here, but don't worry about it. All this is showing you is that there is a data frame method. And you'll see this on tutorial sites. They want to create a small data frame to show you the functionality. And it's a lot easier than like, having a file to download and then you read it in or whatever. So they just create a data frame, a small sample data frame in the code that you can cut and paste off of a web browser. So it's handy to know this. So we are creating a data frame basically from a dictionary. We've got a dictionary, which you remember are keys and a list of values. Key value, key value, key value. So we are creating a data frame that will have the columns, name, office, age, and favorite, and then the values will be Michael, John, Graham, Eric, and each one has 4 values. So it's a dictionary where the value for each key is a list, kind of like you would think. I'm kind of, that's the way it operates. Okay, so we're going to create that Python's data frame because these are the Monty Python players, and then we'll print it out. Okay, so there's our data frame. We could also do Pythons.head, close print. Or I'm curious here if we do Pythons.info. Yeah, we've got one numeric column. So if we do a describe, we're only going to get one column's worth of information, right? Because the describe only can describe numeric data. Oop, what did I do wrong? Pythons dot, oop, it's not desc. That's descending in syntax in SQL. Is that right? Not describe. Good grief, man. There you go. So that is this cute little data frame that we just created in code. We didn't read a file in. All right. put my toys back where I found them, get rid of that code cell. Okay, so what part of this table is the actual data? See how here on the left column, we've got 0, 1, 2, and 3. That's not in our pd.dataframe code up here. You don't see 0, 1, 2, and 3. Those are implicit. That's an implicit index. So by default, we get integer row index values. What if we wanted to use the values in our name column? Well, gosh, there's a way to do that. And that is to specify the index as you create the data frame. Okay, so here we're going to do the same thing, but we're specifying that each row has these indexes. Michael, John, Graham, and Eric will be the unique value for each row. And our column names are age, favorite, and office, which are up here, and you don't have to list them in order. So how about that? Office, age, and favorite. So you'll see that very often you don't need to refer to these things in order because you're using the actual column name. All right, let me run this. Bam. So now our index is Michael, John, Graham, and Eric, but it's not a column named index. It's just the data frame. It is the data frame index. So there you go. That's how that works. Okay, what part of this table is the actual data and what has changed? Well, the name is no longer a named column. It is now the index. You can see that difference up here. And what else has changed? Besides moving from the name being a column and the index being a system assigned integer value, what else is difference between this one up here? I'm up here, guys. What's the difference between this one and this one? I'll rerun it with the print statement so that it looks the same. What else is different?
The formatting looks different.
Does it still look different? Because I changed them. Now I'm using print in both of them now.
Before you changed it, it had like a line underneath the headers and stuff.
Yeah, before I changed it. That's the difference between just typing the method or just typing like the name of the object and typing print the object. The print command formats things a little differently than the output from just the method does. But what I'm moving you towards here is just the columns are different. The column order is different. It's in the order they were created. So anyway, there you go. What part of this table is the actual data, the age, favorite, and office columns? Okay, so we can subset a data frame just like you can, hide columns, select a certain column in an Excel spreadsheet, or filter by certain rows. You can do all that same kind of thing with a Python data frame. So we often want to work with a subset of the overall data frame. So there's basically 3 ways, just like in Excel. You look at columns that you want to look at, and in particularly machine learning, that's attribute reduction. You keep hearing me calling columns attributes of the data, or by row. Which if you didn't download this new one this morning, I added the word filtering here because Mike had it as just slicing or sampling. That's the slicing and sampling is kind of the Python sort of syntax, but really what you're doing is filtering. by row, right? When you only look at certain rows in a data set, generally you think of that as a filter. But you can also do both. Okay, so to select a single column, you just put the name of the column in quotes, string literal name of the column. And it's got to be perfect. It's got to be the right case and everything. So Python's age brings back the age column and the index. Michael, John, Graham, and Eric. Remember, the name is the index column. If we had implicit indexing, 0, 1, 2, 3, 4, 5, 6, it would return those numbers as well. If we just print out, if we just use the method or the object, if we just use the data frame object, if we put that in print, it's going to look a little different. If we print Python's age, it just looks a little different. Actually, I don't think print did anything different that time. Okay, so I get for going off script. Anyway, Python's age looks at just that column. The next one, favorite, looks at just favorite. And for some reason, before I had put the wrong, I added the word, S, there is no key error favorites. That sounds like a dictionary error, right? Key error. So all of this Python is wrapped up in the same universe. So there's the favorite column. So that's how you deal with one column is by putting one column name in quotes. Okay, so let's extract the location column and put it in a different object. Okay, so we can subset the data and store it in another variable, and it'll be the same data type, So location df equals and good old df was what, like Applewood CSV way back. We'll find out here in just a minute. Actually, I wanted it before I move on. Add a code cell df dot head. What in the world was that? That was way back. Yeah, that's that Applewood up at the top of the page. Get rid of that. Okay, so back to good old df variable that we declared earlier. We're going to pull out just the location column and put it in another data frame, and then look at that data frame. So it's a data frame, even though it's not, even though it's only got one column, it's still a data frame. Okay, so what is the type of that object? It is a series, Panda series. So I lied. Disregard what I just said. When you pull one column off of a data frame, it converts it back to a series object, not a data frame. So this is actually a bad variable name. Can you all forgive me? As long as I just go faster?
Yeah, it's fine. It didn't really bother me from before.
Okay, well, it should. You should have gone, hey, Walker, that's not going to create a data frame. It's going to create a series. You're only pulling one column out of the data frame. Of course, it's going to convert it to a series object. No, I'm just kidding. I don't expect you guys to get corked up like that. I think I'd freak out if any of you actually came off mute and yelled at me like that. Okay, so yeah, if you pull one column, because a column in a data frame is a series, if you pull one column out of a data frame, it makes it a series object. Okay, However, comma, in our next section here, we're going to select multiple commas or multiple columns. And this syntax took me a long time to get through my head. Okay, to deal with multiple columns in a data frame, whether it's displaying them or moving them over to a smaller data frame where you're only pulling the certain columns that you need, just like you delete a lot of junk columns out of an Excel spreadsheet. The way you would do that in Pandas is to grab the columns that you need and put them in a new data frame that, you know, kind of an edited data frame. So we're looking at df.head, which is our Applewood thing here. So we've got a numeric index because we didn't change the index. We got age, profit, location, vehicle type, and how many previous owners. These are like cars for sale or something like that. This data set is actually out there on the internet. So when you are referring to a single column, it's in brackets, right? It's in the square brackets, just like we did up here. DF location. So you've got to refer to one column in a data frame, you just put that one column in quotes. But if you want to refer to more than one data frame in square brackets, you have to pass it a list, and a list has to be in square brackets. So you wind up with the square brackets that you would put your, for lack of a better word, your index in. And then you have the square brackets inside of that are the list of column names that you want to deal with. And that I forget that double bracket all the time until I'm deep into it and I've been using it and get used to it. So anyway, that's the syntax. So yeah, df.head, we got age, profit, location, vehicle type, and previous. And that can be very handy because if your column name is complex at all, you can always reach up here to a df.head output and you can highlight it and copy and paste it so that you make sure you get the column name perfectly correct. So if we want to display the first 5 rows with the .head method of only these columns, we have to enclose them in extra square brackets because that's a list of values that you are passing as your, for lack of a better word, as your index value. Okay. So that's how you refer to multiple columns. Everybody tracking? See, now we're only seeing location, age, and vehicle type. We haven't gotten rid of the other ones. We're just looking at those 3 columns, the first 5 rows of those 3 columns. If I go back and just do a regular df.head, we'll see it overwrites that, and we'll see that it has not changed. Okay. Practice. Okay. Extract the profit and location columns. So you're going to be dealing with 2 columns instead of 3 like we have up here. Everybody listening? Because I'm going to pick somebody at random and we're going to do share your screen.
Yeah.
So you're going to extract the profit and location columns from DF here. Hopefully you've been coding along and running your code like I have. And then you're going to assign the result or save the result in a new object called sub1df. Now, if you got, this isn't fair. If you guys are using the older version of this, if you didn't download this right this morning, the answer's right in front of you. So that's not going to be fair. I just thought of that. So never mind. I'm not going to play tricks. I'm just going to type it out and you're going to You're going to watch me do it. But if you don't, if you downloaded this right before class and this is blank, who does not have the answer in front of them? Be honest. Be honest.
I just downloaded this morning, so I don't have anything in there.
You don't have anything in there. Was that Alyssa? Who was that?
Yeah, it was me, Alyssa.
Alyssa. All right. Share your screen and let's code through it.
Give me 1 second and try to figure this out. Okay, this is what I have.
Woo. Okay. So down in that practice column extraction code cell, how would you satisfy the requirements of that practice? You're going to extract 2 columns and save them in a new data frame called sub1_df. That's 1 line of code.
Okay. I am not sure. The past 10 minutes I've been getting like probably 10 emails back to back, and I've been like back and forth. So I missed a couple things.
Yeah,
I'm really sorry.
that's a frequent issue of doing these at work.
Yeah.
It happens all the time. And people, you know, your supervisor says like, oh yeah, great. They're going to be in training. And oh yeah, that's fine. And then they swamp you and pull you away on meetings. And anyway. All right. So I'm gonna, okay. So first line of code, we're going to assign something to a new data frame called sub1_df. So how would that line of code start out? An assignment statement to sub1_df.
So the variable is sub1 df.
Yeah.
Okay. Is it just
So we're going to set, yep, you got it.
Like that?
sub1_df equals, yep. And now we're grabbing from the df data frame. So go ahead, type that in from df. And now we need, well, we're not going to call a method. We are going to subset the columns in the df data frame. So we need 1 open bracket. And of course it will plunk in your close bracket. So we need 1. If we were just going to pull 1 column out, we would be okay to put it in quotes. But since we're pulling 2 columns out, that's why you need 2 sets of brackets, because we're going to pass it a list of column names. There's only going to be 2 things in that list, but we're going to pass it a list of column names. So we need another bracket. And then we need a legal Python list of 2 things. So we're going to extract what are the 2 column names? Where it says practice, it tells you to extract 2 column
okay?
names.
Yes, that's what I was reading. Sorry, I was
Yeah,
reading the
yeah.
end of it. Profit and location.
There you go.
So I don't need the quotes.
No, you still need the quotes. Anytime you refer to a column name, they've got to be, and it, so what's your, yeah, there you go. So that is and then, so you've got a legal Python list there, but you need a close bracket for the list. And then you need a close bracket for the data frame indexing thing. That's why you need 2 square brackets. And until you get some practice with that, it's a pain, but that's what it is. It's just coincidence that they're using the same symbols is why it looks crazy like that. Okay, so we are extracting those 2 columns from the original data frame and saving the result in that. And what do you think, Chris? Do you think she's got that line of code complete? Christopher?
Yep.
You-
Sorry.
That's all right.
Um,
Does that look right?
I think we're missing a piece. The dot head portion of it.
True. But that's an assignment statement. That's an assignment statement. We're
Is
missing.
that when you display the first 5 rows?
Cor-
The head?
Yeah, head. Yeah, you guys talk it over.
Well, I'm looking at the previous one. Head displays the first 5 rows. Do we need to do the first 5 rows for this one as well, or not really?
Nope. It says inspect the
Okay.
last 8 rows. But
Okay.
that's a good point to put in there. We don't want to assign the last 8 rows with the dot tail method. You know what I mean? You could, I guess, theoretically try and do this all in one line and put tell you what, Alyssa, just out of pure curiosity, put dot tail open paren 8 right where you got right now. And what is that? What that is saying, looking at it, is give me the last 8 rows of just the profit and location column. That's what that looks like. It's an assignment statement though. It's not using the print function, which is what it says up in the, in the practice extraction. But just out of morbid curiosity, execute that line and see what happens. Yeah, you can't.
Okay, so I don't have the list.
Yeah, you can't. Yeah, you got to do it in a separate line of code. You can't. So go back up to your code, get rid of dot tail. Hit enter, go to the next line. And now it says use the print function to inspect the last 8 rows. So what would that look like? Hey, you're rolling.
To do print. So if I just do DF, that would show the whole thing, right?
Yeah, we're
Like
looking
the
at
whole list?
yeah, we're looking at our new data frame that we just assigned.
Oh, sorry.
And then you want to look at the last 8 rows. So what method would that be?
So could I use tail here? with the
Well,
print?
if you put it at the end of the line, you're assuming that the print function has a sub method called dot tail. So it wouldn't go at the end of the print function. It would go right where your cursor's blinking.
Okay.
Booyah.
Okay, I think it's because I don't have like the data frame in here. Like I've
Let's
just
see.
been,
Oh, you
haven't
haven't
been
run. Oh, yeah,
executing.
yeah.
yeah, I haven't been executing. Yeah, that's why. But if you put this in yours, we can see how it runs.
Well, yeah, if I could do that. So let me, yeah.
I can stop sharing.
Yeah, stop sharing. Okay, good job, Alyssa. On the spot. They call that the hot seat. And when I was running the coding academy, they did a lot more of that than I do. It does take some time, but for everybody in the hot seat, it sure does make it more meaningful. So let's see what we called it sub 1 underscore df equals df, and then we needed a square bracket, and we needed another set of square brackets since we're passing in a list. And it was I always use capital P profit, and then double quotes, profit and location. And then we were printing sub, and if I hit tab, curious if, yep, sub, that's the only thing that starts with the letters SUB. print sub1 df tail. 8 characters. df. Oh, that's not right. I'm sending in a function, not a method. Somebody should have said, "Hey, Walker." Okay, so I got one open paren for the print, one open paren for the tail method. Close paren, close paren. I got all my quotes. I got left paren, right paren, right paren. So I'm gonna go, please work first time. Look at that. Bango. There you go. So that was our practice. Okay, so we can, so that was grabbing particular columns out of a data frame. And you can name them. We'll get into it a little bit, and you can grab them by position, column 1, 2, 3. There's multiple ways to go at anything, but that was how you select particular columns. Now, selecting specific rows, this loc and iloc, 2 ways to go at it. Loc is the index value, like DF was our good old Applewood, the cars thing up here. So the first row of that data frame has the age equal to 21, profit equal to 1387, locations Tianesta, vehicle type is sedan, previous owners is 0. So that's the first row, and I'll go up here and prove that. Yeah, here's our dot head. Those all line up, 1387, Tianesta, yeah. Okay, so we can, if we use loc, we can grab the index values. Now, this is, I got to go through the syntax of this, but I don't usually wind up operating this way. But this is the loc command pulls up the actual, the index value here, this from this left-hand column. It just happens to be the same as the integer position. Okay. So depending on the data, it's the same thing. Okay. How do we decide between loc and iloc? How would we get the value from one specific cell using this technique? Okay, so we're going to grab here from the data frame, we're going to pass the row and the specific columns. So we're just getting age and profit as we subset this data frame and getting rows where the index value is 0, 14, 41, and 113. So that's how you do like double, row and column is row, comma, column. Rows and columns. And that comes in really handy. I've done some processing where, no kidding, you're going through and iterating in a couple of different loops through a set of rows and then across columns, and it works pretty well. But there's the syntax using the LOC, the loc method. Okay. Now slicing a range of rows or columns. That's from like row 4 to row 12. Now we get into the left inclusive, right exclusive, where it's up to but not including a number. And there are 2 different sets of rules. I didn't make this stuff up, guys. This is Python. It's write exclusive when using iloc, which is the actual number, but it's write inclusive when using loc, which is the actual index value. So yeah, it's confusing. Let's do a couple of examples, but it uses slicing that looks just like the string slicing that we did in that notebook. I think it was notebook 6 in strings. From this to that, and the third optional parameter is a skip by how many numbers, how many to increment. So if we look at the first 10 rows of our good old DF data frame, and we want to use iloc to pull 3 to 8, iloc is write exclusive. So we won't see row 8 because we're using the iloc function here. 3 to 8. So it's up to, but not including 8 because we're using iloc. And this third, you don't need this comma. It's an optional parameter. So it's the same thing to leave if you leave that comma out. But now we're going to use slicing and in the loc method, which is write inclusive. So we're going to see from 38 to 44, but we are going to see 44, but we're also passing the column list. Remember, it's row, comma, column in the loc function. Those are the two parameters you can pass to loc, the column being optional. So we're passing a slicing statement for the rows and column names, a list of column names as the column parameter. Bam. So we see, because loc is write inclusive, we do see value at 44. I know. Just and when you start working with this stuff, it's just you'll be off by 1, and that's why it is, because some things are write inclusive, exclusive. You just got to remember what you're looking at there. Okay. So our Python's data frame, remember, was our Monty Python players. So Python's from Eric to Eric is using the index value by default. If you don't pass anything, if you don't use a method, it's saying give me the row, because if you don't specify anything in this slicing, it's like it's using the loc function behind your back or something. It operates under the same rules. And if we look at Python's from John sliced to Eric, we get Eric because it is write inclusive, like the loc function. It's like it's using that by default behavior without you looking at it. And we'll get into more of this. We will get into, I've got a notebook on common wrangling tasks, and we'll have a few more exercises here. My voice is giving out. I can feel it coming. Okay, so we can do Boolean conditions within a data frame, but you have to remember to pass. We're dealing with a data frame. It's not just a series. So you have to remember to use the data frame in your condition, not just like age. You don't refer to Python's is a data frame. So you can't say like Python's, let me comment this out. It might be intuitive for you to say Python's age greater than 67. If I were to say, show me everything in that data frame where the age is greater than 67, It might be intuitive to do that, but it doesn't work that way. It doesn't know to go to that column and do the vectoring and all of that unless you refer to the age column in the right syntax, which is as part of a data frame. So that's why we have to have not this syntax, but the one before that's in your notebook. So this is saying, show me the Python's data frame where the Python's data frame column is greater than 67. So we're looking at the whole data frame, see? Okay. So I'm pretty sure this is the same thing that we were doing before with Applewood. I'm gonna press on and we're gonna be done for the day. So we're reading cars is the Applewood data set, which I think is what we were just doing. Yeah, age, profit, location. So now we got a data frame called cars instead of DF. So now we're creating our edited data frame, sub cars. We're creating that from the cars data frame. Give me all of the cars data frame where the age column is greater than 67. And then we'll look at the first 6 rows of that. So now we've filtered out everything out of the cars data frame where the age is less than 67. Boy, those are old cars. Good grief. So now here we're filtering rows or subsetting, whatever you want to call it. We're filtering rows using a conditional expression. So this thing is saying, show me cars where cars location column equals Olean. So that will filter out anything of Sheffield and Kane and Tionesta. So we're only going to see Olean. Now it doesn't modify the data frame. This is just a display. When you just type in the object, you just get a display. So now we only have Olean locations. But that's how those sort of things. And then you can combine and get all fancy to filter out rows. You could use a multiple condition there. Let's try that real quick. Now that I've said it, I want to do it. And if I screw it up, I'm just going to move on and beg you to forgive me. So what's another condition we could put in here? We have filtered where location equals Olean. What's another compound condition we could add to that condition?
You can make
Anybody?
like the age over 30 years old or something like that.
Okay, so we didn't filter it. So, okay, so cars. So I'm going off script here. So and cars bracket age. Whoop, gotta have the quotes. If anybody, as I'm typing, you're all welcome to come off mute and go. You forgot. And age is what'd you say? Was that Alyssa or Jeanette?
That was Jeanette. I was
Jeanette.
saying greater than 30, maybe.
Age greater than 30. That looks syntactically correct. Does anybody see a problem with that before I hit run?
I think you need another bracket in front of the bracket in front of the age, but I could be wrong. Oh no, you're fine.
Yeah, I always count them. That's I got.
Yeah, I found the other one. I couldn't. Yeah, at
One,
first I was like, you're
two,
missing
three.
one, and then I saw it.
1, 2, 3. I know, and boy, when it gets more complex, one missing. Oh, yikes! So anyway, that looks to me like logically like what I'm trying to do in English. Let's see if it's correct in Python. Nope. The truth value of a series is ambiguous. I know I know how to do this. I just can't remember the syntax without wasting your time. And is anybody seeing what I'm doing wrong and want to come off mute and say, Don, you forgot that da-da-da-da-da. I'm trying to do a multiple condition. I'm trying to just show the cars from Olean and that have the age of that are greater than 30.
It doesn't need like an equal greater than 30, does it? Because the
Eh,
problem with
shouldn't. No, that's
yeah, I
mean,
don't think it should, but
greater than or equal.
Could you try like how you did cars and then open bracket cars location equals Olean? Could you close that and then do the and then do it over cars over bracket
Maybe.
cars? Would
Let's
that
see.
work?
Let's see. I know there's a way to do this. So like, is that what we're talking about? Closing off each condition in its own parentheses? Is that what?
Maybe. I was thinking like you can close off the square bracket
Yeah.
after Olean.
Oh, hang on. Let me get rid of what I just did. Ah,
You see what I'm saying?
yeah, I do. I think I do. So we're subsetting cars where location equals Olean. No, I thought I was following you mentally, and now when I look at
Okay,
it,
so after the closing quotes for Olean, could you close the bracket? Like put a close bracket
well,
there.
then I'd have an unequal number of brackets, I think. If I just did a closed bracket, whoop,
Oh no, sorry, I meant like the square bracket.
yeah. If I put that there, now I have
Yeah.
an imbalance in my number of brackets.
Doesn't that
So-
close the other one?
Maybe, hang on. So we
Like
got
do it again. It
one.
highlighted the starting bracket. Put the closing bracket back, and then they both highlighted green.
Let
Am
me
I
run it.
seeing that wrong? Okay, and then
Invalid
maybe put
syntax,
the
yeah.
and then start it over again. So have cars, open square bracket, cars, age is greater than 30.
Like that?
No, put cars
Uh-huh.
without the bracket. So delete
Ah.
the bracket that you just put in. Put cars. And then open bracket and then cars again.
Ah,
And then open bracket. Yeah. And then
Like-
close off the last
and
one.
then
at
close off the
end.
last one.
Yeah. I'm wondering if that'll work.
I'm wondering. Let's see. So each thing is kind of like its own. Each condition is in the same syntax at least. And cars
Yeah.
age. Cars location. We'll try it. Bam. No, let me take it for homework.
Yeah.
It won't be today, but yeah, you can do multiple conditions. I just can't remember the syntax. Okay, so let me get rid of all that. Put my toys back where they were. Did that right? Was that? Yeah. So that's back to running correctly. Okay, get rows for previous customers who made at least 3. So yeah, that's another simple one. This is bugging me.
wait, will you go up 1 second? I think,
Yeah.
have you tried putting an and sign instead of the actual word and?
The ampersand?
I just want to see if that would make a difference.
Maybe. Let me.
You got me on a hunt now on my
Yeah,
my
I
own
know,
one. I'm
but,
like trying everything.
But it's. I probably have this. Let me just look real quick. Now, shoot. That's what happens when I get off script. I'm like, oh, cool, yeah, and I want to solve it. I want to go Google it, but I'm looking at this now, and I'm trying to solve a multiple condition here, like this one. This was where previous is greater than 2. Okay, so I think there's a condition. There's a subsetting condition. Okay, so I'm copying that condition and I'm moving it up here and I'm saying, and that condition. I know there's just something real simple I'm doing wrong. Just real simple. So I'm going to take that for homework and we'll talk about it next time. Multiple conditions when filtering rows in pandas. Okay. And here we can, you can always, here we're creating a row that looks like our Python's players, our actors from Monty Python, and you can append a row to a data frame. So we've just added Terry to our data frame. You can add a column, which you frequently do. So here we're going to create a new series object that is aligned with and using the same index values as our Python's data frame. So this just creates a series, but it's got the same index values. Notice they don't have to be in the same order, just like a dictionary, just like anything else, that it uses that value. So here we created a Panda series. And oh yeah, just to go back and remember what we looked like. And now we're going to add, append this shoe size column to the, and by default, it puts it on the end of the data frame. So if you create it correctly, if the data is wrong, if the series does not align, you use the wrong index values, or you don't have enough or whatever, it barfs on you. So that's how you add a column to a data frame. You can also drop a column, and this is, I don't know if we've covered this or not. Somebody tell me here in just a second. Okay, so we're going to drop shoe size that we just appended to that data frame. Okay, so one line of code, Python's .drop shoe size, axis equal 1. I don't know why. I mean, you said shoe size. We got a column named shoe size, but Python requires occasionally you to specify whether you're talking about a row or a column. 0 is a row, 1 is a column. So this drop command dropped the column shoe size. And oh, by the way, let's tell it it's a column. That's the syntax. But then when we go back and look at Python's again, shoe size is still there, because this, like a lot of other things, it doesn't actually make the change. It just returns the data frame without that column. So you could assign that to another data frame, and that another data frame would not have the shoe size column. Or you can say in place equal true when you want to save it to the actual place that you did it. I know it's confusing. So here we're going to say Python's 2, and we'll look at Python's 2, and it actually dropped it because we assigned it to a new one. But if we did this line of code with in place equal true, like here, and don't let me forget to put this back. No. Whoop, where'd it go? What happened? Python.drop. Oh, sorry, I got it wrong. I got a parenthesis in there I don't need. So now it actually dropped the shoe size from Python's because we said in place equal true. So let me put this back where I had it.
Hey, Don, I got that thing to work.
You got the multiple condition thing?
Yeah.
Cool. Hang on just a sec. That's about it. And this is just for your reference. You can write a CSV back out once you've done all of this jingling, jangling, ringling, wrangling of data. You save the resulting data frame as a CSV. And that is what data engineering using Python looks like. You do all of this, pulling out specific rows, pulling out specific columns, changing formats, narrowing things down, getting things all lined up. And then you can do a SQL insert straight from Python, or if that CSV file is going to be used by Power BI or whatever, you write it out, that new one out as a CSV, one line of code, and out it goes. So it works like a champ. I'm not going to mess with that because I'm going to let, oh, and here's working with an Excel spreadsheet. Same thing. You just got to tell it which worksheet. So we're not going to play with this, but there is the syntax for your use, for your reference. And we're going to pop over and work with database files and then do some homework next time on Tuesday. So let me stop sharing and let Seth, what were we missing?
You needed that ampersand, and then you had to take out some of the brackets and put parentheses in.
It's ampersand instead of and.
Yeah, you're encasing, you encase each condition within parentheses, right?
Jeanette, didn't you ask me to use the ampersand? I think Jeanette asked me to do that.
Yeah, she did. Sorry, she just got up to do something.
Sorry, I went to throw away something. And I was like,
Jeanette,
"Ah."
you were right. You were right. I got tired.
I'm excited. I was Googling around how you can like pandas two conditions together, and all the examples had the and sign. And so I was like, let's just try that.
You were right. I should have done it, but I was afraid I was boring everybody. So Seth, go ahead and share your screen real quick and show us that.
This is kind of exciting because I've never used Python. So I'm like, wow,
I know, I love it. It's frustrating, but when you get it to work, it's like, yay, it's like solving a Wordle or something. So that's all we had to do was enclose the conditions in parentheses and use the ampersand instead of and. Like I said, guys, I can't remember. I got so many syntaxes floating around in my feeble old mind. I can never remember them right off. But yeah, so now you're getting at how in very few lines of code you can start wrangling data, and within these, you can call the upper operator, and you could upcase location to be capital OLEAN. You can format data, do all kinds of stuff, filter it, get rid of columns you don't need, and then save that CSV out. Interactive Python is cool because you can kind of wade through the data and look at the results in real time. But to me, what makes this really more powerful is if you were to get it working and then pull the code out of a Jupyter notebook, stick it in a Python script, and then run that whole script without you having to actually supervise each little segment of the code like you do in a Jupyter notebook. To me, that's the real power, even though it is cool. And in this case, when you're doing like a tutorial, having it in Jupyter Notebook gives you the information and the ability to, to try it yourself, like they say on W3 Schools. So cool. So that's pandas. We'll do some hands-on stuff with it here in a probably not next week. I think I want to concentrate on manipulating the data. So data wrangling, understanding the data, that portion of the data analysis life cycle. And then move into charting probably the week after. Like I said, we've got 2 really cool workshops coming up on July 19th, which I think is 2 weeks from Tuesday, where we're going to learn about NoSQL databases, MongoDB, and how to query NoSQL data, like JSON and like XML. And that's going to be a 1-day workshop. Just kind of follow along and follow the bouncing ball. And I don't think we'll do any hands-on. I think he'll show you how to get started. But he's going to basically just show you how NoSQL technology works. That's July 19th. And then we'll do some advanced analytics August 2nd with Dr. Ellis. So yeah, here coming up in the next couple of weeks, we'll continue wrangling data in pandas and doing all of the sorting, filtering, converting sort of stuff. And then we'll do charting, and then we'll do a project with Python where you will use a Jupyter notebook to walk someone through an exploratory project, kind of like we did with Excel, but the notebook will stand alone, almost like a, like a presentation or a PDF or whatever, a paper that you could give to someone else, and they could bring it up and duplicate what you're doing with your code, maybe change parameters or whatever, or use a different input file, whatever the case may be. So that's what's coming up over the next few weeks. And then after that, we will do a segment on Power BI. Some of you are going to be ahead of me. I think Jeanette and Alyssa are learning. Are you guys going through a Power BI segment now, kind of in parallel?
Yeah, we just finished up a Power BI course.
Cool.
How do you just
Yeah. Are you able? Do you have the Power BI service there at Affirma?
Yeah, we do.
You do. So you can publish reports and kind of show the difference between what it looks like in Power BI desktop, and then once you've published elements of those reports to the Power BI service on a dashboard.
Mhm.
Ooh, well, if you would,
Yeah, no, like it said, like it was.
Um,
We did that for.
look into being able to share that, because that's the limitation I have. Is I don't have the Power BI service and a multi-student, so I can't publish the results. I can just go through the mechanics of creating a report.
Can you not get into?
So be thinking about that. We got a few weeks.
Yeah, I'll look into it.
Cool. All right, guys. Yeah, we'll do a little more yapping on Tuesday, but that's going to be mostly hands-on lab day, messing around with pandas. All right.
All right. See you next week.
All right. We'll see you next week.